Okay, now we have one critical point at x equals 0. Notice the x equal minus 1, which was a solution, is an asymptote. An asymptote can never be a critical point or a max-min. So I only have one critical point. I have to find out, is this a max or a min? I'm going to use the first derivative sign test of 0. So I go to the right of the number line and test 1. I go to the left. Normally I would choose minus 1, but remember, minus 1 gives me an asymptote. So I'll go between minus 1 and 0 and solve that. And what I want to find, the first derivative of minus 1/2 and the first derivative of 1. So what we get from here is, I'm not going to bother to go through this, but what we get from here, when you substitute into the first derivative, you're going to get that this is greater than 0. I've done this enough. And this is going to be less than 0. So we have f prime here, minus 1/2, is greater than 0. And f prime here, 1, is less than 0. So if this is, I'm sorry, I think I mixed it up. Yes, okay, I'm sorry. What you're going to get, my apologies, I did it reverse on here. This is less than 0, and this becomes greater than 0, and that makes sense given what we have. Okay, so this is going to be less than 0. Well, let's correct that. It's right on your notes. This is greater than 0, so this is minus, and that's plus, so we get this. So obviously, as you would expect, x equals 0 is at a minimum point. So now we have that, and let's look at the next thing that we want to do. C says, find all inflection points and find the point of diminishing returns of f of x. F of x could be cost here or profit. And I'm going to put down if any. And I'm going to put down if any. Now, how do we find, we know an inflection point, as I've taught you before, is a point where the curve changes concavity. It can change from concave up to concave down, or concave down to concave up. So let's see what happens here. The way we do this is we get the second derivative and we set it equal to 0. So let's go back and look at the first derivative. And what I'm going to do to be consistent with yours, I'm going to use the first derivative that you have on your sheet, because it'll be easier, because this gives me a chance to do the chain rule, and it'll be easier to follow on your notes since the teaching moment that I did before has passed. But your first derivative was this, when you did the chain rule and you didn't expand. So I'm going to use this. This is from your notes. So now I'm going to take the second derivative. Once again, this is a quotient. So I'm going to take the bottom times the derivative of the top minus bracket, the top, times the derivative of the bottom. Over the bottom, squared. And close bracket. Thank you. Now, Okay, so we're back to actually, we're now coordinating with your notes. So how do we do this? Well, this is going to involve a chain rule here. So let's erase this part of the board and go through this chain rule. If I can find my eraser. Here it is. Okay. So far we found the asymptotes, we found critical points, and now we're finding inflection points. This problem actually encompasses almost everything we can do in chapter 10. So, let's take this f double prime x and x plus 3 to the third, x plus 1 to the third. The derivative of 2x is 2 minus, where am I? Down here, 2x. And this one is the chain rule. Now, let's call the chain rule A here. I'm going to bring it out, and it's going to be divided by, it's x plus 1 to the squared to the third is going to be the sixth. Notice 2 times 3 is 6. Okay, 2 times 3 is 6. So let's look at x plus 1, 3. So the derivative, this is A, I call this A, of x plus 1 to the third. Okay, I'm going to let u equal x plus 1. du dx.
That looks like a 5.
Oh, so this is the third. Du dx equals 1. And the power is 3. And the coefficient a in front of that is 1. And we put that into our chain rule machine, which says that dy dx is a n u to the n minus 1 times du dx. This becomes just a plug-in. So dy dx is going to equal to a, which is 1 times 3, u, which is raised to the 3 minus 1, and du dx, which is 1. So we have here 3u squared, and when we substitute back the u, we get 3 times x plus 1 squared. Okay, now that should check with what you have here. So now what I want to do is put that back into here. So I'm going to put a back into here. Okay, so I'm going to rewrite that whole thing and put the a back. And what is a? A is simply this. The derivative of x plus 1 to the third, which is the chain rule. So f prime double prime x, what's that? I invented a new prime system. X plus 1 to the third. Let's put the 2 in front of here. I like this better. This satisfies my mathematical soul. Okay, 2x times 3 times x plus 1 squared divided by what? X plus 1 to the sixth. All right, now, well, I cannot distribute this across here because this is to a third power. In order to do this, I would have to expand this to a third power and then do it. I can only distribute this if this was to the first power. So I can't do anything with that. What I can do is do this. I can multiply the 3 times the 2. That doesn't do much for me. But now notice I have an x plus 1 squared here and an x plus 1 to the third here. I can factor out the x plus 1 squared. So I'm going to factor x plus 1 squared from the numerator. Just I'll call it num. So what do I get for x double prime x? Notice I'm factoring this out. The denominator stays the same. I'm factoring x plus 1 squared. What does that give me? That gives me 2 x plus 1 to the 1 power minus 6x. Why? Because I factored it out from there. Factoring out from here, if I multiply this times this, I get x plus 1 to the third back. If I multiply this times this, I get my x plus 1 to the squared back. So now I can distribute this now because this is to the 1 power. But before I do that, I'm going to divide the numerator and the denominator. I'm going to have to go down here by x plus 1 squared. So I can put that over here if you want. I can put divide by x plus 1 squared. Divide by x plus 1 squared. All right, I don't have a lot of room on this board, so I have to compress some things. Sorry, but you do have the notes where I've done it out a little bit better. Okay. So what happens when I divide by x plus 1 squared here? That cancels. What happens when I divide 6 by 2? I subtract 6 from 2, and I get x plus 1 to the fourth. So f double prime x is going to equal 2. Well, let me expand this to 2x plus 2. 2x plus 2 minus 6x over x plus 1 to the fourth. I can simplify that a little bit more too. And hopefully we get what we got here, right? F double prime x comes out to equal to minus 4x plus 2 over x plus 1 to the fourth. Or if we want to write it in a different form, 2 minus 4x over x plus 1 to the fourth. And that's exactly what I have down here. Now this is the second derivative. In order to find my inflection points, I have to set the second derivative equals 0. So minus 4x plus 2 over x plus 1 to the fourth equals 0. Multiply both sides by x plus 1 to the fourth. This cancels. Minus 4x plus 2 equals 0. Minus 4x equals 2. And what does x come out to be? Equals minus 2, I'm sorry. And x equals 1/2. And now we will have to test whether this is an inflection point.